Okay, in the last video, we left off naming 3-methylheptane, and we kind of went through a process of naming an alkane that has a substituent on it. Remember, that's an atom or atoms that are attached to the parent chain. So the first thing we did is we identified the parent chain, and we saw that in this example, the parent chain wasn't as easy to identify as in the other example, because going straight across what your eyes might want to do normally would only give you 6 carbons. But actually, if you follow the chain and going down this way, which is another potential route, would give you 7 carbons. So you want to start to get used to kind of looking at these molecules in different ways than just left to right, because often the parent chain is not going to be left to right. So you need to get comfortable kind of orienting your view a little bit differently. And we named this molecule as 3-methylheptane. That's because we have a 1-carbon substituent here called a methyl group. The substituents you do need to memorize the name of. And the substituent ended up being at position 3. I could number the chain from left to right here, but that would give me the methyl at position 5. And you want to number the chain so the substituents have the lowest number. So 1 to 3 this way from right to left is better. The 3-methyl tells us we have a methyl at position 3. Heptane, a 7-carbon chain. So now we're going to look at a more complicated example, and although this molecule may look a bit alien-like at first, we're going to have to get comfortable kind of seeing these crazy looking things and realizing, well, it's not that bad once you kind of understand what's going on. And the first thing that we always want to do in every single case is identify the parent chain. And this might be a bit overwhelming here because you see a lot of different potential starting and ending points. Now, in this kind of an example, I could count and see that, okay, if I started from simply left to right, I would get 1, 2, 3, 4, 5, 6, 7 carbons, so that would be heptane. But let's just say, for argument's sake, I started here. 1, 2, 3, 4, 5, 6, 7. So now you kind of run into a case where there's a lot of equal ways to number it versus it being like an obvious numbering way that there's an extra carbon, so it would be a longer chain. In this kind of a case, it's perfectly reasonable to just number it in the most obvious way from left to right, or to rather make the parent chain the most obvious way from left to right. And that's perfectly fine when there's, multiple routes that get you to the same answer. Left to right will always be what you want to do. That's always kind of the go-to way of identifying the parent chain. So this would be the parent chain in this case. And I do want to just really kind of hit on this one more time because it's a bit confusing. But if you're able to make the parent chain just simply across and get the most number of carbons, you want to do that. It's only in the cases where there's kind of an alternate route where you want to use that if you get more carbons. But if they're all the same, like this way is the same and this way is the same, doesn't matter. You just want to go simply across in that kind of a case. So we did identify the parent chain here, and we said that this was heptane. So 7 carbons. And now the next thing on our rule is that after we identify the parent chain and consider the terminal carbons, we want to name and identify any substituents. So we do have quite a few here. We have 1 here. Whoops. We have 1 here, 1 here, 1 here, and 1 here. Do notice that this one, and this one are the same, so those are 1-carbon substituents. And if you recall, we call a 1-carbon substituent a methyl group. So this is a methyl group here, this is a methyl group here, and this is a methyl group as well. They're 1-carbon substituents. And then we have this thing kind of coming over here, and we can see that this has 1 carbon, 2 carbons, and 3 carbons. Remember that this carbon here is part of the parent chain, so it can't be part of the substituent. So there's only 3 carbons here, and a 3-carbon substituent is called a propyl group. So now we've identified the substituents, and we're going to number the chain to give the smallest number to the substituent first. So we want to make sure that the substituents have the lowest number possible. So we can kind of see that this one's a bit more obvious. If we go from left to right here, we'll hit 1, 2, 3. The first methyl will be at position 3, but going from right to left would put the first methyl at position 2. That's better because the substituent would have the lowest number possible. So it's not kind of either or in these cases. When you can put the substituent at a lower number, that's the right answer. So you just got to keep that in mind. So we'll number this parent chain going across. So 1, 2, 3, 4, 5, 6, 7. And now in this kind of a case where I have a little bit more going on, I kind of like to make a little bit of a table on the side, kind of the puzzle pieces, and then put it all together. So we have heptane, that's 7 carbons. We have a methyl at position 2, 3, and 5. So we have methyls at those positions. And we have a propyl at position number 4. Now I am going to add something to our naming rule list over here, and that is to alphabetize substituents. So when you have a molecule that has more than one substituent, you want to alphabetize them when you're naming it. And I'll show you that in a second. Also, use prefixes for more than one of the same substituent. So you'll see what I mean in just a second with this example. But we would say if there's 2 of the same substituent, that's di, 3 of that is tri, and we're going to see that we have trimethyl in the next example over here. 4 is tetra, 5 is penta, and 6 is hexa. We really don't see any more than 5 or 6 of the same substituent on a molecule. So here you can see that we have 3 methyls at position 2, 3, and 5 respectively. So that would be trimethyl. And how do we want to name this chain, or name this molecule rather? We want to alphabetize it. So comparing the propyl to the methyl, M comes before P, so the methyl would go first in naming. So here's how you name a molecule with more than one substituent. So you first are going to put your higher priority substituent, so in this case that's the methyl, in alphabetical order. So at 2, 3, and 5, so you always put the position number dash the substituent. Because we have 3 methyls, we put trimethyl here. We cannot simply put 2, 3, 5 methyl. That doesn't make any sense because that would imply that there's a single methyl at 3 positions. So these positions indicate 3 methyls, and we follow that up with the tri. So it has to say trimethyl if there's 3 methyls. Here's where the slight modification comes. We're not going to go straight to the parent chain name here because we have another substituent. So we're going to continue the process and put a dash, indicate the number of the next substituent, which is propyl, and now tack on the parent chain name. So before, when we were looking at 3-methyl heptane, we just had this part because we only had one substituent. Now we have an additional substituent, so we kind of continue the process until we hit the last one, and then it continues with that same format. So just to recap what this means here, 2, 3, 5 trimethyl indicates 3 methyl groups at positions 2, 3, and 5. 4 propyl means that there's a propyl at position 4. And heptane indicating a 7-carbon chain. So this is how you would name a simple alkane with more than one substituent.